So in today's class, we will be taking up some practice questions from the chapter of quadratic equations. Okay, since we have done a couple of classes on this chapter, so we'll be first of all we'll be taking up some basic, very simple questions on the chapter just to increase our understanding of it, and then we'll try to do some interesting questions from there as well. Question: if 1 minus p is a root of x square plus px plus 1 minus p equal to 0, then the roots of the quadratic are. What be the roots of the quadratic? It's very simple, basic question.
So 1 and minus 2.
नहीं यार, options में नहीं है. Okay, let's try this. So if 1 minus p is a root of this equation, then what should 1 minus p do? Must satisfy the equation. So 1 minus p whole square plus p into 1 minus p plus 1 minus p is equal to 0, which is like writing 1 minus p taken common, 1 minus p plus 1 is equal to 0. ठीक है ना? So this implies 1 minus p is 0, or we get p is equal to 1. Okay. Now, if p is equal to 1, so what happens to the quadratic? X square plus x equal to 0. And what be the roots of x square plus x equal to 0? X taken common, x plus 1. So the roots are 0 and minus 1. Okay. Next question. If p and q are the roots of the equation x square plus px plus q is equal to 0. Find p and q. Answers?
Sir, P is 1 or minus 1 by 2, and Q will be minus 1 by 2 or minus 2.
नहीं यार, ये तो नहीं होगा.
Sir, 1 and minus 2.
Okay, let's see. So if p and q are the roots, then p plus q must be minus p, sum of the roots. And product of the roots, pq must be equal to q. Now, but if pq is equal to q, so what can we say from here?
P equal to 1. P equal to 1.
There are two possibilities. Either p is equal to 1 or q is equal to 0. This equation would be written as q taken common, p minus 1 is equal to 0. So product of two factors is 0, either of them is 0. So दो possibilities है, either p is 1 or q is 0. Now, if p is 1, so we put that over here, case 1, p is equal to 1. So we get 1 plus q is minus 1. So what we get for q? Minus 2. And case 2, if p is 0, so we get 0 plus q is equal to 0, which would imply q is 0 as well. So there will be two possible answers for this question. Usually what happens is people neglect this q equal to 0 wala part, and because of which the answer is wrong. So we get either p is equal to 1, q is equal to minus 2, or p is equal to q is equal to 0. Two possible answers for this.
आपने केस 2 में P को 0 लेके किया है, पर Q 0 होना चाहिए.
Sorry. It still give the same thing, but हाँ ठीक है, correct. Q is equal to 0 है, तो p plus 0 is equal to minus p, which will give us 2p is equal to 0, therefore p is 0. ठीक है, so still get the same thing, p is equal to q is equal to 0. So these would be the two answers. Okay, next question. If the equation x square minus bx by ax plus c is equal to m minus 1 by m plus 1 has roots equal in magnitude but opposite in sign. Find m. What is the condition for the roots to be equal in magnitude but opposite in sign?
B equal to
B of the quadratic has to be 0. So, well, first thing first, we'll have to simplify this expression and get it into the form of a proper quadratic. So we cross multiply. This would be like a m plus 1 x square minus b times m plus 1 x is equal to ax times m minus 1 plus m minus 1 times c. Take everything on the same side. So m plus 1 x square minus b times m plus 1 plus a times m minus 1 x minus m minus 1 c is equal to 0. So this would be the quadratic written in the proper form. And since we want b of the quadratic to be 0, so then according to the problem, b times m plus 1 plus a times m minus 1 is equal to 0. Now from this, try finding m. So bm plus b plus am minus a is equal to 0. Or that will be like m times a plus b is equal to a minus b. So the value of m is a minus b by a plus b. Okay, next. If alpha beta are the roots of a square plus b square times x square plus twice of ac plus bd times x plus c square plus d square is equal to 0, where a, b, c, d belong to real numbers, then option A, mod alpha is not equal to mod beta. Option B, alpha is equal to minus beta. Option C, alpha is equal to beta. Option D, alpha is 1 by beta. Let's make a small correction. Option D, alpha is 1 minus of 1 by beta.
Sir, can you just scroll to question number 2 once?
Question number 2. Yes, 2.
Done, sir. Thank you.
Okay. So in order to find the relation between the roots, well, which entity do we go to whenever we have to look at the nature of the roots? D. So we'll look at the D of this quadratic. 4 times AC plus BD square minus 4 times A square plus B square into C square plus D square. Let's look at what is happening with the D of this quadratic. So this would be 4A square C square plus 4B square D square plus 4ABCD minus 4A square C square minus 4C square D square minus 4A square C square and a minus 4B square D square. So A square C square B square D square will cancel off with A square C square B square D square. अच्छा ये 8 हो जाएगा ना 4 2 8. Okay, next we take 4 common from the remaining expression minus 4, let's say. So we'll have a C square D square minus 8A minus 2ABCD and a plus B square C square. Sorry. A square C square. Okay. We'll have A square C square, A square D square. Then we'll have a B square C square and a B square D square. Okay. So ये वाला टर्म होगा A square D square minus 2ABCD and यहाँ से आएगा B square C square which is like minus 4AD minus BC whole square. Now, what can we say about the nature of the value of minus 4AD minus BC whole square? Now, AD minus BC whole square is a perfect square. So, the perfect square will always be greater than or equal to 0, but it is multiplied with a minus 4, implying D of this will always be less than or equal to 0. But it is given that alpha, beta are the roots of this equation. Okay. Alpha, beta are the real roots of the equation.
सर इसका d लेस देन इक्वल टू 0 क्यों होगा?
AD minus BC whole square is a perfect square. Any perfect square will always be greater than 0. Multiplied with a minus 4 will become less than 0.
Okay.
Okay. But it is given that the alpha beta of this are real. The roots are real. So for real roots, the condition is d greater than equal to 0. But here we are getting d less than equal to 0. When will the two conditions concur?
when D is
0.
equal to 0.
D is equal to 0. Okay? Both the relations can only be true when d is equal to 0. But then if d is equal to 0, what do we get for the roots?
They are equal.
The roots are equal. So the answer is alpha is equal to beta. Okay. Next question. If every pair of the equations x square plus px plus qr equal to 0, x square plus qx plus pr equal to 0, and x square plus rx plus pq is equal to 0. If every pair of the equations among this has a common root, then find the sum of the roots and the product of the roots. Find the sum of the roots and product of the roots. If every pair of equations have a common root, what should the roots of these equations look like? So if we say that the roots of this are alpha beta, तो इसका रूट क्या हो जाएगा? अच्छा, एक तो
Alpha
इसको
gamma.
पहले वाले के साथ शेयर करना है. So let's say alpha is the common root,
Alpha
and then
comma
gamma is the non-common root. And in that case, what will be the roots of the third equation?
alpha
Alpha
comma
Alpha
beta.
delta.
Beta gamma. Alpha क्यों होगा? The roots are common pairwise. So first
Okay.
and second will have a common root. Second and third will have a common root. First and third will have a common root. All
Okay.
three do not have a common root.
Okay.
Okay, every pair of equation has a common root.
Okay.
Is everyone able to understand the distribution?
Yes, sir.
So if we take the roots of the first as alpha beta, then the second would be like alpha gamma, and then that'll make the third as beta gamma. So now our objective is to find the sum of the roots and product of the roots, which essentially over here means like we have to find alpha plus beta plus gamma. and alpha into beta into gamma. ये निकालना है.
सर एक बार फिर से समझा सकते हैं वो अल्फा गामा और बीटा गामा क्यों है?
Because every pair has to have a common root. So first and second में there should be a common root. Then second and third में there should be a common root. And then second and third में भी there must be a common root.
यस सर.
So इस रूट को अल्फा अज्यूम कर लिया, इस रूट को बीटा अज्यूम कर लिया और इस रूट को गामा अज्यूम कर लिया. That's how the distribution comes about.
ठीक है सर.
So now quickly, how do you find alpha plus beta plus gamma and alpha into beta into gamma? So from the first equation, what would be alpha plus beta? Minus P, and alpha beta hoga QR. From the second equation, what is alpha plus gamma?
सर आपने जो एक फॉर्मूला दिया था कॉमन रूट का, हम लोग वो भी तो लगा सकते हैं.
पर क्या नीड नहीं है यार. जो क्वेश्चन में पूछा है and the way the question is designed, it's not needed. And beta plus gamma would be minus R and beta gamma would be PQ. Now, using these set of equations, how do we get a alpha plus beta plus gamma and alpha into beta into gamma?
ऐड एंड मल्टीप्लाई कर
Add and multiply कर देंगे, सही बात है. इसमें first equation में भी add all three. Add all. So this would be twice of alpha plus beta plus gamma is minus of P plus Q plus R. So the sum of the roots, alpha plus beta plus gamma, would be minus of P plus Q plus R by 2. And इसमें we multiply all. So that will give us alpha beta gamma whole square is equal to PQR whole square. So in that case, alpha beta gamma will end up becoming PQR. Isn't clear on this?
Yes, sir.
यस
Okay.
सर.
Next question. Rohit and Virat solve a quadratic equation. अब दोनों रिटायर हो गए हैं तो और क्या ही करेंगे.
ऑल्टरनेट टाइमलाइन.
In solving it, Rohit made a mistake in the coefficient of x, in the constant term actually, in the constant term, and got the roots as 5 and 2. While Virat made a mistake in the coefficient of x and got the roots as 6 and 2. Now, your job is to find the actual roots. What would be the correct roots?
सर रोहित मेड अ मिस्टेक के बाद आप क्या लिखे हैं?
In the constant term. Rohit made a mistake in the constant term. ax square plus bx plus c में गलती कर दिया.
सर विराट कोएफिशिएंट ऑफ एक्स में गलती थी.
हाँ, and Virat made a mistake in the coefficient of x. उसका b गड़बड़ा गया.
पापा तो आप बोल रहे थे अपनी बुक बुक तो आप दिखाना चाहते थे कितने पेजेस की है
Sir, 4 and 3.
Okay. So let's try solving this. So if we assume that the original quadratic is ax square plus bx plus c equal to 0. Now considering that Rohit made a mistake in the constant term and got the roots at 5 and 2. So that means for Rohit, coefficient of x was correct. So in that case, if the actual roots are alpha and beta, then alpha plus beta must be equal to 7 for some of the roots to correct hai Rohit ka. Right. And similarly for Virat, he made a mistake in the coefficient of x, implying iska constant term correct hai. So for Virat, the product of the roots is correct. So the actual roots are such that these are, their sum is 7 and their product is 12. So in that case, what would be the roots?
Sir, 4 and 3.
4 and 3.
4 and
Sum
3.
7, product 12. Is the question clear? It's a very simple question. Next question. If x1, x2 are the roots of x square minus 3x plus a equal to 0 and x3, x4 are the roots of x square minus 12x plus b is equal to 0. Now, if x1, x2, x3, x4 form an increasing GP, find A and B. If x1, x2, x3, x4 form an increasing GP, find A and B.
One, one, four, three.
Okay. So we solve this one like this. X1, X2, X3, X4 form an increasing GP. So we can consider them as A, AR, AR square, AR cube. Now, considering that X1 and X2 are the roots of the first equation, so we'll get A plus AR is equal to 3. And the product, acha, A to is already given. Good job, good job. Avoid confusion, avoid confusion. Let's have it as A, AR, AR square, AR cube. Just to avoid confusions, because here A or B already question be given. Hai. So we'll have A plus AR is equal to 3. And A square R is equal to A. And from the second equation, we'll have AR square plus AR cube is equal to 12. And यहाँ पे product हो जाएगा A square R power 5 is equal to B.
पापा मुझे आज ज्यादा आपके साथ चाहिए
Now simplifying the first equation, we can take AR square common and we'll have a 1 plus R, which would be 12. And similarly, in this equation, we take A common. So A into 1 plus R would be 3. Now, substituting this result over here, we get R square is equal to 4 or R is equal to plus minus 2. Now, out of plus minus 2, which value should we take?
+2.
+2 क्योंकि स्क्वायर है.
We take R as 2 because it is given that it's an increasing GP. So mod R has to be greater than, R has to be positive. R has to be greater than 1. So now if R is 2, so what do we get for A? यहाँ डाल दो, तो A आ जाएगा 1. So A is 1, R is this, so A कितना हो गया? A का 1, 2, and how much would be B? B would be like 2 to the power 5. 2 to the power 5 is 32. That will be the answer. Next question. If B1, B2 is equal to twice of C1 plus C2, then at least one of the equations x square plus b1x plus c1 equal to 0 and x square plus b2x plus c2 is equal to 0 has option A, real roots, option B, imaginary roots, option C, purely imaginary roots, and option D, none.
सर
Hmm.
इमेजिनरी और प्योरली इमेजिनरी में क्या डिफरेंस है?
Imaginary roots are in the form of A plus IB, where purely imaginary roots are in the form of IB only. A 0 होता है.
ओके.
सर वो B1 into B2 लिखा हुआ है क्या?
हाँ, B1 into B2. B1 into B2 is this.
मगर
So whenever we have to comment on the nature of the roots, we go and take a look at D. So that's the same thing that we'll do over here. So look at D1. D1, that's like D of the first quadratic. So D1 of the first quadratic would be B1 square minus 4C1. And D2 of the quadratic, second quadratic, would be B2 square minus 4C2. Okay. Now notice, if we do a D1 plus D2, तो ये आएगा B1 square plus B2 square minus 4 taken common, C1 plus C2. But what is the value of C1 plus C2 given in the question?
B1
It's like B1 B2 by 2 by 2. So this ends up becoming B1 square plus B2 square minus 2B1 B2, which is like writing B1 minus B2 whole square. Now, since D1 plus D2 is now, since the expression is B1 minus B2 whole square, so what can we say about the nature of its values? It's a perfect square, has to be greater than or equal to 0.
Yes, sir.
Yes,
You
sir.
know, but if sum of two numbers is greater than or equal to 0, it's like D1 and D2 यहाँ पे, sum of two numbers is greater than or equal to 0, then what conclusion can we draw from this? Can we say that at least one of the numbers must be greater than 0? एक नंबर तो पॉजिटिव होना ही होगा ना?
Yes, sir.
मतलब greater than or equal to 0, it's possible that D1 D2 दोनों 0 हो. So at least one of the numbers has to be greater than or equal to 0, because if both are negative, तो sum of two negative numbers तो positive हो नहीं सकता. So either the case is both the numbers are positive, या फिर एक number negative and एक number positive, with the positive value being the larger value, thereby the net result being positive. So if at least one of the numbers, that is to say, either D1 is greater than or equal to 0 or D2 is greater than or equal to 0 for sure. But either of them becoming greater than or equal to 0 will imply what? That at least one of these equations has real roots.
Real roots.
So the answer is option A. At least one of them will have to have real roots.
पर सर हम लोग को ये तो नहीं पता कि दोनों का डी वो 0 भी तो है, वो भी तो एक केस हो सकता है.
हाँ, तो दोनों का 0 होगा तो भी तो रियल रूट्स ही तो होगा. D equal to 0 is also the case for real roots. Equal to 0 भी तो रियल रूट्स में ही आता है.
मतलब इसमें इक्वल और डिस्टिंक्ट का कुछ नहीं है.
हाँ, इसमें इक्वल और डिस्टिंक्ट का कुछ नहीं है, रियल और इमेजिनरी पे चेक करना है.
और अगर
इक्वल और डिस्टिंक्ट का चेक नहीं कर सकते.
अगर इस यहाँ पर आता है रियल एंड इक्वल रूट्स, तो अब हम लोग क्या आंसर को टिक करते?
नहीं, रियल एंड इक्वल इज नॉट द करेक्ट ऑप्शन.
तो ऑप्शन डी होता.
हाँ, ऑप्शन डी होता, बिकॉज वी कैनॉट कमेंट फॉर श्योर कि रियल एंड इक्वल ही होगा. यू ऑलवेज हैव टू मार्क द मोस्ट अप्रोप्रिएट आंसर. So real and equal is not the most appropriate answer for this. Equal हो भी सकता है, नहीं भी हो सकता है. It's not a general statement.
Okay.
You know. Okay, next question. If one root of the equations x square minus 6x plus a equal to 0 and x square minus cx plus 6 equal to 0, if one root of the equations is common and the other roots are integers in the ratio 4:3, find the common root. Find the common root. If one root of the equations is common and the other roots are integers in the ratio 4:3, find the common root. So for the quadratics, what can we assume the roots as? एक रूट
Alpha,
कॉमन है,
beta, alpha.
so उसको तो अल्फा ले लिया, and the other roots are in the ratio 4:3. So can we just say that the other roots is like 4 beta and 3 beta, where beta will be an integer because the roots are integral?
Yes, sir.
We can assume the roots as this: alpha comma 4 beta and alpha comma 3 beta. So from the first equation, what relations can we write? Alpha plus 4 beta is 6 and 4 alpha beta is A. And second equation से क्या आएगा? Alpha plus 3 beta is C and 3 alpha beta is equal to 6. Now using this as equation 1, this as equation 2, solve simultaneously. Using these two as the basis, solve the two equations simultaneously. What do you get for alpha beta?
Alpha is 2, beta is 1.
Alpha is 2, beta is 1. Okay. So we'll quadratic में change करेंगे. We need alpha. So let's say we put beta as 2 by alpha. तो यहाँ पे आ जाएगा alpha plus 8 by alpha is equal to 6, or alpha square minus 6 alpha plus 8 is equal to 0, which is alpha minus 4 into alpha minus 2 is equal to 0, which gives us two values. Either alpha is 2 or alpha is 4. But if alpha is 2, so beta would be 1. And if alpha is 4, so beta would be half. Now, in that case, the second set of values will get rejected. Why will it get rejected?
Because beta is integral.
Yes,
Because
is
beta belongs to the set of integers. Beta has to be an integer. So we get alpha as 2, beta as 1 as the answer for this.
सर ये सेकंड वाला रिजेक्ट ही हो जाएगा, फिर से बता दीजिए।
क्योंकि बीटा हाफ आ रहे हैं ना, but we know that beta has to be an integer. बीटा इंटीजर का केस है ना.
ओके सर।
Okay, next question. If tan A and tan B are the roots of the equation x squared plus ax plus b equal to 0, then find the value of tan A की जगह tan alpha कर दो. If tan alpha and tan beta are the roots of the equation, क्योंकि a and b यहाँ पे है equation में, so alpha beta कर दो. Tan alpha, tan beta are the roots of the equation x square plus ax plus b equal to 0. Then find the value of sine square alpha plus beta plus a times sine of alpha plus beta cos of alpha plus beta plus b times cos square alpha plus beta. Find the value of this. Okay, how do we solve the question? If tan alpha and tan beta are the roots of this equation, so we start by writing down the relations. So tan alpha plus tan beta would be minus a, and tan alpha into tan beta would be b. So that means tan of alpha plus beta. Now the formula for this is tan alpha plus tan beta by 1 minus tan alpha tan beta is, so tan alpha plus tan beta हो गया minus a divided by 1 minus b. This will end up becoming a by b minus 1. Okay, so that will be the value of tan of alpha plus beta. Now, from the expression that we have, to solve it, we take cos square alpha plus beta common. तो ये बन जाएगा tan square alpha plus beta plus a times tan of alpha plus beta plus b. And इस cos square को we can actually shift in the denominator as sec square, and sec square को लिख देंगे tan square again in terms of tan square again. So this will be tan square alpha plus beta plus a times tan of alpha plus beta plus b whole divided by 1 plus tan square alpha plus beta. अब सब जगह पे वैल्यू प्लग इन कर दो. Tan of alpha plus beta is a by b minus 1. So a square by b minus 1 whole square plus a square by b minus 1 plus b whole divided by 1 plus a square by b minus 1 whole square. Now taking the LCM, b minus 1 whole square to cancel हो जाएगा. So we'll have a square plus a square into b minus 1 plus b divided by b minus 1 whole square plus a square.
सर
So
b के
simplifying
साथ
again, a
b
square.
माइनस वन होल स्क्वायर भी होगा.
सर बी के
क्या?
साथ बी
b के साथ
के
b
साथ
इंटू b माइनस वन होल स्क्वायर.
हाँ 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 राइट. b के साथ b minus 1 whole square भी होगा. राइट. We will have a square plus a square b minus a square plus again b into b square के साथ देन आ जाएगा b cube plus b minus 2b square divided by we'll have a square plus b square plus 1 minus 2b. तो अब क्या सिंप्लीफाई हो रहा है? तो a square cancel हो गया. From the numerator we can take b common, so we'll have our a square plus b square plus 1 minus 2b divided by a square plus b square plus 1 minus 2b. तो ये cancel हो गया. What is the final answer? B. The value of this expression is B.
सर आप टॉप लेफ्ट कॉर्नर में tan अल्फा प्लस tan अल्फा लिख दिए हैं, वहाँ पे tan अल्फा प्लस tan बीटा होगा.
तो tan alpha plus tan beta ही तो है.
नहीं नहीं सर, ऊपर टॉप लेफ्ट कॉर्नर में.
अच्छा tan alpha plus tan alpha कर दिया. Okay, right. Sorry. हाँ. So moving on, question number 10. If sine alpha, sine beta, and cos alpha are in GP, then the roots of x square plus 2x cot alpha cot beta plus 1 equal to 0 are in are A real, B real and negative, C real and greater than 1, D imaginary. So we have to comment on the nature of the roots. So obviously we'll look for D. So if the three values are in GP, so what can we draw? What relation can we write? Sine square beta would be sine alpha, cos alpha.
Cos alpha.
Okay. And since we have to comment on the nature of the roots, we look at the D of the quadratic. So D of the quadratic would be 4 cot square beta minus 4. Now 4 cot square beta minus 4 is like 4 cot square beta minus 1. But then what is cot square beta? What would be cot square beta minus 1? Cot square minus 1 को we can write as cosec square.
Yes, sir.
ये हो जाएगा 4 cosec square beta. And cosec square beta will end up becoming यहाँ से क्या आ जाएगा cosec square beta is 1 by sin alpha cos alpha, which is 2 by sin 2 alpha. So 2 cosec 2 alpha. Yeah, in any case, ये तो 4 cosec square beta है, तो cosec square will anyways be greater than 0. So the roots would be real.
सर cot
cosec
square
square
beta minus
beta
1.
कैसे आया?
क्या चीज?
Cot square beta minus 1 है, plus 1 नहीं है, तो cosec square beta कैसे हो?
Sec cosec square अच्छा cosec square is 1 plus cot square होता है ना, तो ये cot -2 हो जाएगा, सॉरी cot square में -2 हो जाएगा, ठीक है, -2 हो जाएगा. एनी केस वैसे ही सिंप्लीफाई करना है. तो ये 4 cot square बीटा -2 है, cot square बीटा के जगह पे आ जाएगा cosec square बीटा -2 हो जाएगा, सॉरी. आप ठीक है ना?
यस सर.
ठीक है, तो cosec square की जगह पे ये आ जाएगा 2 cosec 2 alpha. So it should be like 8 times cosec 2 alpha minus 1. Yeah. Now what can we say about cosec 2 alpha minus 1? Yeah, let's write it in this way. 8 by 1 plus. इसमें ज्यादा इजी रहेगा समझने में. Now sin 2 alpha will always be a number less than equal to 1. So 1 by sin 2 alpha क्या हो जाएगा? It will always be a number greater than equal to 1. देखो ये समझ में आ रहा है ना? So in this case, t will be greater than equal to 0, hence the roots are real. Okay, next question. if alpha beta are the roots of ax square plus bx plus c equal to 0, then alpha by a beta plus b plus beta by a alpha plus b is option A, 2 by A, option B, 2 by B, option C, 2 by C, option D, none. So, well, since alpha, beta are the roots of the equation, so we can say that they must satisfy the equation. So, we'll have a alpha square plus b alpha plus c is equal to 0. Now, alpha taken common, a alpha plus beta is minus c, or that will give us a alpha plus b, sorry. A alpha plus b is minus c by alpha. And then correspondingly, in a comparison scenario, we can say that a beta plus b will be minus c by beta. Now, if you look at the expression a alpha by a beta plus b plus beta by a alpha plus b. So a alpha plus b, a beta plus b is minus c by beta. So this would be like minus of alpha beta by c minus alpha beta by c, which is minus twice of alpha beta by c. So now alpha beta is c by a. So it will end up becoming minus 2c by ac. C cancel over here. We get the answer as minus 2 by a. So the correct answer is D, none of these. Next question. If A, B, C are distinct real numbers in AP, and the roots of the quadratic ax square plus bx plus c equal to 0, are alpha beta such that one by alpha plus one by beta, alpha plus beta, and alpha square plus beta square are in GP, then find the value of A by C. A very simple question. So if A, B, C are distinct real numbers in AP, so what will be the condition of AP? 2AB is equal to A plus C. Now the second condition that we have over here is 1 by alpha plus 1 by beta. By the way, how much is 1 by alpha plus 1 by beta? Minus of B by C. And alpha plus beta. So alpha plus beta is minus B by A. And alpha square plus beta square is B square minus 2AC by A square. So according to this, we will have B square by A square is minus of B by C into B square minus 2AC by A square. तो एक A square कट गया, एक B और एक B कट गया. So this will end up giving us BC is equal to twice of AC minus B square. Okay. Now, which is like writing we have to eliminate B from this, the two equations. Okay. A और C का relation चाहिए, so we have to eliminate B from this equation. So let's continue then. तो B की जगह पे substitute कर दो AC plus A plus C by 2. So this will give us A plus C by 2 into C is 2AC minus A plus C by 2 whole square So this would be AC plus C squared by 2 is 2AC minus A square plus C square plus 2AC whole divided by 4. Now, if we take everything on the same side, so we will have A square plus C square plus 2AC by 4 plus AC plus C square by 2 minus 2AC is equal to 0. Now, taking the LCM, this will end up becoming A square plus C square plus 2AC plus 2AC plus C square minus 8AC is equal to 0. Clubbing the similar terms together, ये आ गया A square minus 4AC plus 3C square is equal to 0. Now we are looking for the value of C by A निकाल देता है या A by C निकाल देता है? A by C निकाल. So now this is like a quadratic divide by C square. So A by C whole square minus 4 times A by C plus 3 is equal to 0. A by C का वैल्यू निकालना है, यहाँ से निकल जाएगा. So this is like having t square minus 4t plus 3 is equal to 0. So इसका क्या हो जाएगा? t minus 3 minus 3t minus 3 is equal plus 3 is equal to 0. So t minus 3 into t minus 1 is equal to 0. Therefore, t is equal to 3 or t is equal to 1, which implies A by C is equal to 3 or A by C is equal to 1. But A by C equal to 1 will get rejected. Why so? क्योंकि क्वेश्चन में ऑलरेडी डिक्लेयर कर दिया that they are distinct real numbers. But if A by C is equal to 1, तो A equal to C हो जाएगा, not possible. So the answer is value of A by C is 3. Clear?
Yes, sir.
We'll stop at this for today.